Welcome back to 5.5 on z-scores. Let's begin. So far, in 5.4 we dealt with normal distribution on bell curves, where we were able to tell where the data fell, 1 standard deviation, 2 standard deviation, or 3 standard deviations away from the mean. Today's question deals with what do we do, how do we calculate it if the data does not fall exactly 1, 2, or 3 standard deviations away? Can we still, answer those types of questions? And for that, we're going to need to use a z-score, okay? Which is a standardized value that indicates the number of standard deviations of a data value above or below the mean. Again, I know, complicated, it's going to be okay. There's two formulas we're going to get. They're right here, okay? To find a z-score, you're going to go x minus the mean divided by the standard deviation. And we're going to practice that in a minute. If you had the z-score and you wanted to find the x value, which we will have to do later today, then you'll go x equals the mean plus z times the standard deviation, okay? Once again, these formulas will be provided to you on a formula sheet for the exam, and we're going to practice them here momentarily. Okay? So here's your first example. It says, determine the z-score for the value of x. So your formula, once again, is z equals x minus the mean. Remember that little u is for this is the mean, okay, divided by the standard deviation. So to calculate this, find my calculator. They've given us the x value. They said x was 174, the mean was 112, and the standard deviation was 15.5. What would the z-score be? 174 minus 112 is 62 divided by 15.5. In this case, the z-score would be 4. Okay? Now, that's not really how a z-score works. That's just how you calculate it. We're going to get into how it works in a minute. Skip that one. This is to find the value of x. I guess we can try this. So this is x equals the mean plus z times the standard deviation. So this will be, the mean is 53.46. The z-score is 8. Oh no. Sorry, I used the wrong formula. This was just another one of the same thing. We'll just skip that one. We already did that. Okay, so a z-score indicates the position of a data value on a standard normal distribution. So for example, if your z-score was 1.5, I'm just going to show you where that falls. That's like saying right there, 1.5. Okay? It falls between 0 and 1 on our normal distribution curve. If the z-score was negative 0.3, that would be right there. Okay? If it was negative 2.4, that would be somewhere over there. Okay? So z-scores and that z-score table handout that I gave you, this is what's going to help you calculate the percentages. Like remember how you were able to calculate the percentages pretty easy when you were told, what percentage is to the left of 1? Then you would just add up all the percentages, 34, 34, 13.5, and 2.35. Now, when you find a z-score of 1.5, for example, you're going to use that table that I gave you, and that'll tell you the percentage that's to the left. And we're going to get into that in just a minute here. So that's sort of what we just talked about. So here's where you're going to get to use these tables. The table tells you the percentage of the data that lies to the left of the z-score. And it says that on the top of the page, the percentage of data that lies to the left of the z-score. Those of you that are watching at home, here is what a z-score table looks like. It looks like this, and you're going to get your own copy when you are in class, okay? And I will do my best to try to show you how this works as we go through. So this is the paper copy that the students in class got today, and you will get one of these when you come tomorrow. Okay, so we'll come back to that in a minute. The first example says the z-score is negative 1.15, okay? It wants us to find the percentage of the data that lies to the left of negative 1.15. So what we have to do is we have to go to our table. So those of you that are in the class, grab your table. Those of you at home, I'll pull the table up.
There's nothing to the left.
Just hang on.
Okay.
You have to find the z-score. So you can see on the z-score, it's these values on the side, on the left side, and on the top. So our z-score was negative 1.15, correct? Is what they asked us for. So let's find that. So I go to negative 1.1. I found negative 1.1 right here. And now I'm going to go over to 0.05, because if I put those together, I get negative 1.15. So that should be right here at, I don't know if I have a way to highlight it right now. Negative 1.15 is right there. 0.12507. So this gives you the decimal value. For you to find the percentage value, you're just going to times that number by 100. So I'm going to go back to the screen here for a minute. We use that table, and we found 0.12507.
What?
When we went to negative 1.15 on our table,
Yeah.
we found that number, right? Now, to find the percentage, we just times that by 100. And our percentage would be,
How do you get that number?
12.507%. Are you on the negatives?
Yes.
You go to negative 1.1 and then go over to where it says 0.05.
Oh, okay. I thought it was 0.5. 0.15.
No, it's negative 1.15 is a z-score. Okay? So what this value means, this 12.507%, 12.5%, what that means is that is the value, the percentage of data that lies to the left of that z-score. So if you were asked, what's the percentage of the value that lies to the left of the z-score, you find the z-score on your table, you get that value, times it by 100, that'll be your answer, okay? There's another example here. This one says, using a z-score table, determine the percentage of data to the left of each z-score. And the z-score here is 1.24. So let's find 1.24 on our tables. I'm going to pull it up for the people watching at home. 1.24, I have to go to the positive z-score pages. So I find 1.2 right here. and then I go over to 0.04, so I can put them together and get 1.24, which will be right here. 0.89251. So hopefully everyone was able to find that number
Yep.
properly. Okay, 0.89251. So now I'm just going to write that down. 0.89251.
But if it's
So-
to one decimal place. 0, 0. Never mind.
Then we times that by 100 to get our percentage. 89.25%. So if your z-score value is 1.24, which is right here, right about there, that means that the percentage of values that are to the left of that is 89.25%. Okay, so you can see why this table, z-score table, is a very valuable resource. Without it, this stuff would be basically impossible. Okay. Next question. This one says to use a z-score table, determine the percentage of the data to the right of the z-score. Okay. The ones we've done so far have been to the left of the z-score. Today we're going to find it to the right. So the process starts the same. Let's find negative 2.35. Okay, I'm going to just look on my paper here. Negative 2.35 is 0.00939. I times that by 100 to get the percentage. I have 0.939%. Because negative 2.35 is a pretty small z-score, right? That's like right here. Okay. There is 0.939% of the data that falls to the left of that z-score. But that's not what the question asked us, right? The question said, what percentage of data is to the right of the z-score? So what we're going to do is we're just going to take our 100% minus the percent that's to the left of the z-score, 939, 100 minus 0.939 equals 99.061%. 99.06%. This is the percentage of value that is to the right. Let me change the color. I can't change the color here. This is the percentage that's to the right of this z-score. Okay? So if it asks you to the right, you find the percentage to the left using a table, and then just go 100 minus that, and that'll tell you the percentage to the right. Okay? The third one, the third type of question they'll ask you is the percentage of data between two z-scores. Okay? So what you're going to do here is you're going to find the z-score. Negative 2.88 is right there. Negative 1.47 is right here. And you're just going to subtract them, okay? Because like this negative 2.88 is right there. The negative 1.47 is right here all the way to the end. So if we subtract them, then we'll be left with just that percentage right there, okay? So in the interest of time, I'll just look up the numbers here. Those of you that are in class can practice finding the numbers as well. Negative 2.88 has a z-score of 0.00199 times that by 100, we'll get 0.199%. That's for this guy. And then for negative 1.47, I get 0.7078 times that by 100. That is 70.78, or sorry,
Yeah.
Is that, do I have that written down right? Negative 1.47. Oh, I'm missing a 0. Negative 0.07078, so 0.07 times 100 is 7.078%. Now to find the area between those two z-scores, I just take the 7.708 minus the 0.199%.
Wait, is the z-score what's in the middle of those dotted lines?
Say that again?
Is the z-score what's in the middle of those dotted lines?
No. Yeah. Well, the z-score, because the z-score doesn't fall on an exact, like, you know how in 5.4 we always were like 1 standard deviation or way or 2. Now it's in between, so the table helps us find the percentages to the left, whereas before we could just add up the percentages, right? Because we fell on exact lines, but now that we're in the middle, we have to use the table to tell us what percentages to the left. You with me? We'll pretend you're with me. Next question. We're going to skip that one in the interest of time because I want to make sure we get to the hard ones. Okay, now sometimes they'll ask you backwards, okay? So far, they've been giving you the z-score and they've been asking you for the percentage, right? So we've been using the outside of the table to find the percentage. Now they're going to give us the percentage and they're going to ask us to find the z-score. So the question says, what z-score is required for each situation? It says 10% of the data is to the left of the z-score. So now what I have to do, I have to go to my table and I have to find 0.1 in the middle of my table. Because 0.1 is 10%, right? So they kind of highlighted it here for us. It doesn't hit it exactly, but if you go to negative 1.28, negative 1.28 will take you to, where are we here? Negative 1.28 is like 0.1033, and that's pretty close to 10%, right? Because if we multiplied that by 100, we get 10.03%. So then what our z-score value would be is negative 1.28 would be our z-score, okay? So if they ask you for the percentage, now you have to go into the table, find that number, and then go out to figure out what the z-score is. You're kind of just doing it backwards. Okay, here's the type of question you could get. Okay, so pay attention to this one. We have 2 examples to go through here before we're done. It says, IQ tests are sometimes used to measure a person's intellectual capacity at a particular time. IQ scores are normally distributed, right? That's important. We want it to make sure it's a bell curve, which it is, with a mean of 100, standard deviation of 15. If a person scores 119 on an IQ test, how does this score compare with the scores of the general population? So if you get 119 on an IQ test, how much smarter are you compared to everyone else? How many people are you better than? So the first thing we have to do is we have to find the z-score. So we go to our formula, equals x minus the mean divided by the standard deviation. They gave us the mean is 100. They gave us the x was 119. And they gave us the standard deviation, which was 15. 119 minus 100 divided by 15 is a z-score of 1.266. So we'll just round it to 1.27. Okay? So now we have the z-score. Once we have the z-score, we can go to our table and we can figure out, we can find that z-score, and then we can figure out what percentage of people fall to the left of that. Okay? So find 1.27 on your z-score table. 1.27 is 0.89796. That's just that's the decimal, right? We times that by 100 to get the percentage. 89.796%. We would round that to 89.8 if you wanted to. So that means that if you scored 119 on the IQ test, that you did better than 89.79% of the population. Okay? So once again, they gave us the X, the mean, and the standard deviation. We calculated the z-score. Then we took the z-score to our z-score table. We found 1.27, and then we had the percentage. Okay? Last one. Oh, there's two left. We'll get through this one for sure. But we might have time for both. It says that athletes should replace their running shoes before they lose their ability to absorb shock. Running shoes lose their shock absorption after a mean distance of 640. Okay, so the mean is 640. Standard deviation of 160. Zach is an elite runner, and he wants to replace his shoes at a distance when only 25% of the people would replace their shoes. At what distance should he replace his shoes? So here they want to know the specific distance. So they want us to find X. That's what they want us to find. We know the mean is 640, and we know the standard deviation is 160. Now, he wants to replace his shoes when only 25% of the people would replace their shoes. So to find the z-score, we have to go to the table. Go to table. They've given us the percentage, so we got to go find 0.25 on our table somewhere. So look through your table, try to find 0.25. Now the process of finding the numbers on the table sometimes takes a little bit of time. Those of you that are at home today, we will go through this tomorrow in person, so you get a chance to practice. 0.25 is, it's between, if you're looking for it, it's sort of between negative 0.67 and negative 0.68. Because negative 0.67 has a percentage of 25 or 0.25143, and negative 0.68 has 24.825. So it sort of falls in between here. So then my z-score, my z-score will be, I'm going to just put it in between here, negative 0.675. Had you chosen to use negative 0.67 or negative 0.68, that would be fine. But because it's sort of right in between, that's what I'm going to choose. Question?
What if there's one that's like point, oh, never mind.
Okay, you're good?
Yeah.
All right, so now we have the z-score. The z-score we found was negative 0.675. Now we can go to our equation, which is x equals the mean plus z times standard deviation. X is what we're trying to find. The mean is 640. Z is negative 0.675. And the standard deviation is 160. So I'm going to go negative 0.675 times 160 is negative 108. So 640 minus 108 And the answer is 532. So if Zach wants to replace his shoes when only 25% of people would replace their shoes, then he should replace it at 532 kilometers. Okay? Next one. Let's do this one. Let's finish with this one here. What z-score is required for each situation? Okay. Here it says 10% of the data to the right of the z-score value. Okay. So you can do this one of two ways. Here's what I would do. The table gives us the values to the left of the z-score, right? To the left. We want it now to the right. So if 10% of the data is to the left, or sorry, to the right, how much data is to the left then? If there's 100% in total, 90. That's right. So instead of calculating 10% of the data to the right of the z-score, because my table doesn't really work with to the right, you know, that's going to be hard to calculate. My table works with the area to the left. So instead of finding 90% of the data to the right, or sorry, 10% of the data to the right, I'm going to find 90% of the data to the left.
Why doesn't it work to the right?
Well, that's just the way the table's set up. All the values they give you, it says it right on the top. It represents the area to the left. So if they want us to find the area of 10% to the right, like if you think about it on a bell curve, right? They want you to find the 10% of data that's to the right here. Well, instead of doing that, why don't we just use our table and find the 90% to the left? It's the same, it's still the same score, right? It's still the same z-score. So I try to find 0.9 on my z-score table, which is, oh my goodness, there's so many numbers. It looks like it is at, the closest one is at 1.29.
Where did you get that?
I went to the middle of my table because they're giving me the percentage, right? The percentage is 90. So I'm trying to find 0.9 in the middle of my table. And then once I find 0.9, or as close to it as I can get, then I just go out 1.29, and that's my answer. I'll help you in a minute.
Why 1.29?
What's that?
Wait, what? Never mind.
Never mind. Okay. Again, I know there's a lot to this lesson, pardon me. We can revisit this again, but we've got to the basics. The z-score and the z-score table will help you find the percentage of values to the left. Okay? Your assignment is in your workbook. On page 127 to 129 of your workbook, and I would recommend probably doing all of these ones for good practice. Okay? Thank you. Have a good day.